Growing Up Weird.
Hi, and welcome to Growing Up Weird, the podcast where we explore how the earliest chapters of Western childhoods shape the health stories that we then carry into our adulthoods. I'm Dr. Greg Dickens, scientist and consultant in medical innovation, and I am here with Dr. Gwen Bradbury.
Hello.
Who is a healthcare researcher, author, and your guide through the science stories and traditional strategies that connect childhood beginnings to lifelong good health. Each week, we dig into the newest evidence, understand how it links together, and walk through some of the changes that we in the West could make to give kids decades of better health. So, whether you're a parent, a teacher, a healthcare professional, or simply curious about how the body and brain develop over time, you're in the right place. Are you ready? Have you got a cup of tea? Good. We're going to do things a little bit backwards today. Instead of starting with the news and then leading on to our main thing and then doing the listener question, we're going to start with the listener question. Where we go after that, your guess is as good as mine. Basically, I have no idea. But let's start with this listener question. The reason we're starting with the listener question is A, it's really topical. It's about the weather, and it's really bleeding hot here at the moment. I assume you're listening from within the UK. Most people do. It's warm. It's sweaty. We don't like it. We're going to complain about it because we're Brits. It's also addresses another listener comment that we had, which is that listening to the podcast made them feel guilty. And that is not the point. I apologise on behalf of myself. I'm not going to apologise for Gwen. She can do that herself if she wants to.
I apologise too. I'm not trying to make people feel guilty.
The whole point of this is that Western culture forces us into an environment that messes with long-term health, right? The stuff you learn on this podcast and through reading Gwen's articles absolutely is stuff to learn. And then it's stuff to get angry about. It is stuff to talk to MPs about, to campaign about, to go to marches.
To talk at schools.
To talk to your school, to talk to
Nursery.
your doctor, nursery.
Yeah.
But it is not stuff to feel guilty about. This is not parents making bad choices. This is parents being offered bad options. Mm-hmm. And we want to change that. So, listen, enjoy, get angry, but don't feel guilty. Wicked. So, what was that listener question that was so topical, Gwen?
The question was, it's really hot at the moment. Should I be worried about my child in the heat?
Oh, interesting question. I realise I should have read it because you're going to be the one answering it.
It is true. So, great question. And yes, you should, because being too hot can be fatal for any animal, and humans are no exception. So yes, there is. If your child gets really, really hot, that is very bad. So you should know the signs of heat stroke, so a child that is too hot. You should also know the signs of sunstroke, which is the child who's been in the sun too long, because either of these can be very severe in the short term. Ways to prevent it: stay in the shade, don't run around a lot in the middle of the day, drink plenty of water. Anything else you'd add there? Sunscreen, if you're going to be unavoidably exposed to the sun.
Yeah, I think those are the standard short-term things that everybody should know, and hopefully everybody does know.
Yeah.
But what's going on here in the longer term?
I think that's the really scary part. And that's because when bodies are stressed by the heat, it drives a metabolic pathway in the body that helps the body survive that short-term period of heat. We've talked about this pathway before in a different context, because it's also the pathway that's activated by sugar and by a Western diet. All of these factors feed in to make a body try to survive. The problem is that if a body is trying to live in survival mode for a long time, like a lifetime, then parts of the body start to fail. So that's how we end up with our Western diseases of heart failure, of obesity, of kidney disease, of fatty liver disease, etc.
And that's coming from the diet.
That's coming from a certain pathway in the body, which is partly activated by diet.
Okay.
And in fact, diet is a really big driver. But there are other factors too. And one of those factors is heat stress.
Okay, and the reason I asked is that you're talking there about a whole lifetime of stimulation of this pathway, whereas I'm imagining that these heat stress moments, although maybe they're getting more common, aren't something that happens every day for your whole life.
That is absolutely true. But the problem is because many different factors feed down the same pathway, even intermittent events can add on to anything that is stimulating that pathway at the same time. So what the data shows, for example, is that heat stress is likely to really exacerbate the effects of a Western diet and a high sugar diet.
Interesting. Okay, so should we worry about the heat? Yes, because it can be properly dangerous in the short term, but we knew that already. And yes, because it can make make it harder to survive on a Western diet in the long term.
Exactly.
Okay, well that is comprehensive and clear. Thank you.
Thank you.
Where do you want to go? News?
Or news or dirt?
Oh,
Spill
news
the
or
dirt
dirt.
or do the dirt? Oh, I
Cake
don't
or
know.
death? Let's do news.
Let's do news. Go for
Let's
it.
do news, and then we can belt through dirt, and it'll be great.
Perfect.
Okay. How many pieces of news you got?
I've got one.
Ah,
If you got more than one again.
I'm sorry. I'll
All
just
right.
do one if you want.
No. Do you go first, then
I've got
me,
a
then you?
stupid one, and I've got a sensible one.
Fantastic.
All right, rapidly then. Iwata et al. From Hokkaido University in Japan. I really hope I'm pronouncing that right. Looked at the Japan Environment and Children study, which looked at something like 200,000 Japanese people back in the day, of whom 74,000 were mothers. And these folks had their blood tested. They looked at long-term outcomes. It was a 10 or 20-year follow-up. Big data set. And as we know, new ways of crunching old data is all the rage in getting published at the moment. And these folks found that people in the top third of selenium intake, or rather blood levels, during pregnancy had children who were more resistant against streptococcal infections.
How delightfully specific.
Delightfully specific. What freaked me out slightly is they also found that people in the top third for mercury levels were resistant, or had children who were resistant against streptococcal infections in children. Now, they reckon that's because selenium and mercury were correlated, and then they did some really interesting mathematics and showed that mercury was nothing to do with it.
Right.
I don't understand the maths well enough to say, is that nonsense?
It feels like
nonsense.
with fish intake. Is that the?
Yeah.
But is that the kind of fish has a good thing, but it comes along with mercury?
No, so selenium's
Brazil nuts.
Selenium's nuts, certain other parts of certain plants, and seafood.
Okay.
Anyway, whatever, doesn't matter. The selenium evidence looks reasonable.
Okay.
I don't know what to mention about the mercury evidence, but what I find interesting about this, A, odd mathematics, B, that strep in kids, the long-term effects here of increased risk of rheumatic fever, increased risk of lifelong kidney problems, etc. Yeah, if just having a few Brazil nuts in pregnancy can work with that, then, as we said at the beginning, we should be campaigning for better access to nice food for mothers. We should not be making mothers feel guilty about their diets. I just want to ram that point home.
Absolutely. I don't think anyone will look back in 70 years and be like, I wish my mother had eaten a few more Brazil nuts.
Well, no, they won't, because they'll be already dead from kidney problems.
No, that's awful.
Oh, sorry.
Terrible.
I'm sorry, I'm not even that sorry. Your turn.
Okay, so another paper came out in the kind of exploring the question of why is it that babies born vaginally have a different microbiome to babies born by C-section.
Okay.
And it's something we've talked about loads, right?
Yeah.
And it's something that, once we started to understand about the microbiome, I say we in a more global sense here, once people understood about the importance of microbiome, suddenly they realised there was this quite significant difference depending on how a baby was born that persists for several years at least, if not longer.
Yep.
And they said, okay, so, how does this happen? And sure, the first thing as well, obviously babies go through the vagina, therefore that must be how they're getting their microbes.
Apart from... Oh, please tell me you're about to tell...
Apart from, there's an increasing body of evidence that actually suggests that the microbes in the vagina are not particularly well correlated with the gut bacteria of the baby. And so it's into this kind of murky swamp of data and sorry, that this new paper has now landed, so to speak, and they asked the question of, where are the babies getting the difference in microbes from? They had 63 babies. This was a paper by Ronde et al. In the BMC Pregnancy and Childbirth Journal. 63 babies, some born vaginally, some born by C-section. The mothers had vaginal and rectal swabs just before delivery, and then the researchers took stool samples at 0, 7 and 28 days from the babies. And they were looking in overlap between genetic signatures in the bacteria between the mother's swabs and the baby stool.
Sure.
So basically saying, are these the same, like very similar microbes? And what they found was that actually there was almost no overlap between the vaginal microbiome of the mothers and the baby stool sample, and there was limited overlap between the rectal swabs of the mother and the stool samples.
I mean, you'd expect that given the massive amount of gardening that milk and etc. The mother's antibodies do to bacterial populations inside the baby.
Exactly. And so do you want to just explain a little bit more what you mean by that? Because I'm with you, but...
Yeah, and I want to ask you whether there wasn't much overlap because one was a subset of the other, or if the baby's getting bacteria from somewhere else.
Yeah, good question.
Okay, so what I meant by the antibody statement is that the mother can change and improve the microbiota and microbial balance inside the baby by putting antimicrobial peptides, pro-microbial foods, etc. into the breast milk. That then enables her to say, okay, here's the stuff you need to be immune against because that's what I've been dealing with over the last couple of months. Here's some stuff that'll help your gut out because it's been helping my gut out for the last 10 years. Here's some other useful gear, and don't let these bacteria get too dominant in your gut. Here's some antimicrobial proteins. It's incredible, the conversation that goes on between the mother's immune system and the baby's gut.
Yeah, exactly. And I think that is one of the pieces involved in the results that they found here, because certainly formula feeding was much higher in the C-section babies in this study. So that's going to be a very big confounder on their data. And actually, even in the quite short term, so a lot of babies born by C-section have a bit of formula because when you have a C-section, it really disrupts the normal hormonal patterns of breastfeeding. So it just makes it really hard for those mothers to then establish breastfeeding. Sometimes establish it at all, but certainly establish it early on.
Yeah, okay.
So I think that formula feeding is certainly a piece going on here. I think I do wonder whether the fact that they only looked at the microbes between 0 days and then 7 days, actually I wonder whether a lot of that gardening had already gone on, because we know that in a new environment you can have enormously rapid microbial turnover as certain species come in and they're quite quickly outcompeted, or they set the stage for the next one.
Like flash succession.
Like flash succession in a kind of ecosystem. So I suspect that might have been part of it as well. I think we've talked as well about the differences between the vaginal microbiome and the vulval microbiome. So people have paid a huge amount of attention to the vaginal microbiome because it's next to the uterus, and because, well, I do think there might be a linguistic thing here because, the general population seems to be much more familiar with the term vagina because it's often, it's this more sexual word than vulva. I remember as a veterinary surgeon having a whole consultation where I talked about this dog's vulva, and then at the end the older male owner was like, what is a vulva? And
why has he bought a car? What's going on?
Yeah, exactly. But yeah, so I do wonder, just linguistically, people tend to think, the vagina is the important part, the vulva is just like, the tiny little bit of the...
I wonder where you were going.
I know, I'm trying to think of an analogy.
The setting. It's the setting is what it is.
Absolutely.
The context for the vagina.
The context of the vagina. But certainly the vulval microbiome's got much more in common with the rectal microbiome than it does with the... All right.
Phones off in class, please. Come on.
Yeah, so the vulval microbiome's got much more in common with the rectal microbiome than it does with the vaginal microbiome. So I do wonder whether there is an important part of that movement through the vulva. I do also wonder whether some of the vulval anatomy is actually partly around seeding the vulval microbiome onto the baby during birth.
Sure. Missing swabbing the vulva is unforgivable when gathering data around birth microbiomes, in my book.
Absolutely. And there's very, very little. I think I've seen 1 or 2 papers looking at the vulval microbiome with regards to birth. But in general, I think the takeaway from this is that if you have a C-section, obviously vaginal seeding has been something that's really of interest, and there's conflicting evidence on it. So if you're going to have a C-section and you're interested in seeding, don't just swab your vagina, do swab your vulva as well. And it feels a bit less medical, a little bit less hygienic, but I can tell you that the microbes you collect from your vulva are much more likely to be those that are beneficial for your baby than those collected from your vagina. And also breastfeed, because it is such an incredible way of shaping a microbiome.
Okay, I feel somewhat gender-wise unqualified to comment on this, but I'm going to add to that.
Go for it.
At risk of pissing off everyone. I think it might be worth mentioning that breastfeeding doesn't have to be entire or complete.
Yes.
Just having whatever small amount of milk is available will do a lot of that gardening and microbiome control, even if it doesn't provide the majority of, say, calories or protein. Sure, calories and protein, brilliant, very important. Without them, you die. But you can get those from formula. Whereas stuff like those incredibly important antibodies and pro-microbial factors, which would cost upwards of £40,000 per gram to make, you can't get those anywhere else. Those come from breast milk alone.
Yeah.
So yeah, even if you can't do much, do some. Hey.
Yeah, absolutely.
Okay.
Great.
There we go. Let's try not to get lynched by angry mothers, which is reasonable.
What's your next one?
Oh, I'm going to double down on the whole manosphere thing here.
Oh, no.
My next one is in the journal Andrology.
Oh, my goodness. Of course, there's a journal.
Proper blokey journal. Here we go. So, Ivel et al. What was this now? 10 days ago in the journal Andrology said, well, we've looked at 2,000 boys at 17 years old, and those 2,000 same again when they got to 24 years old. And we have previously proven that INSL3, I'm not going to tell you what that stands for because I can't remember.
Okay.
But it is a marker from the Leydig cells in the testicles of their ability to control testosterone production.
Okay.
Right? So testosterone from the testicles is not stable. It doesn't just, there's not just a level. It increases and decreases in response to hormones from the pituitary for start, and a bunch of other markers in the blood. You get inflammatory disease. Your testosterone goes, I can't even remember which way it goes, but you get changes in testosterone as a bloke in response to things going on in your life.
Yeah. When you're stressed, you don't feel like it.
Precisely.
Yeah, got it.
But INSL3 apparently is a good marker of how well your testicles can do that. And since efficiency of testosterone modulation is important for later health, and this has been well proven. By the way, if you can hear small children chattering away, it's because the three have been sent to bed and they're chattering away very happily upstairs. Please don't let it detract from the quality of your podcast experience. Bing! Okay. So look, two prior pieces here. One, we have found this chemical. It's a good marker of how well you can do testosterone leveling. Two, testosterone leveling is really important for adulthood health as somebody with testicles. And then the piece in this is we looked at 2,000 kids and then their later adults and found that if they get fevers in infancy, bad fevers in infancy, or they're obese when they're entering puberty, it knackers their ability to produce INSL3.
So that means they can't make enough testosterone?
It means probably they can't control the amount of testosterone they've got very well, and probably they can't make enough in general, but it's certainly not very variable. And that probably reduces their later adulthood health. There are a couple of links here. So this is a piece of the puzzle, and you have to rely on the other papers being correct for this to actually make any sense in general. But if those papers are correct, and they look pretty good to me, then hardcore fever in infancy or lots of estrogen producing fat in the body at the beginning of puberty both reduce your testicles' ability, well, not yours, but mine, testicles' ability to produce and level testosterone throughout adulthood, which then reduces your health.
Does it affect your fertility as well? Is that?
Oh, almost certainly.
Yeah.
But I was...
Oh, no, obviously
That's
not the focus of this
a
podcast.
secondary benefit.
Yeah, of course.
But we're talking about immune health, bone strength, muscular strength, cardiovascular health, the ability to pull off a cool hairstyle, ability to look like James Dean. I don't know. Just
Fascinating.
the health benefits of having enough testosterone and being able to level it for a man in adulthood are well understood.
Can I ask one other question, slightly provocatively?
You absolutely can.
I thought testosterone was part of the reason that men typically live less long than women. Does it have any effect on longevity, do you think? Or is that balancing is...
Interesting. So you are absolutely right that that testosterone is implicated in the fact that we die sooner, on average. However, it's also well evidenced for keeping us fit and healthy into old age.
I see.
So sure, we burn out sooner, but I'd rather have a healthier old age and burn out sooner rather than have a worse old age and still burn out sooner.
Yeah, it's true. Yeah.
Yeah. Chimps, on the other hand, testosterone through the roof. They die at like half the age we do. So yeah, you're right. Testosterone may well be a...
But they do have enormous testicles, right?
They do.
This is what-
Tiny, weird-looking penises.
This is big bets.
We accidentally watched some chimp sex the other day at the zoo, and my God, it was over quickly.
It was underwhelming, wasn't it?
It was underwhelming. Yeah. She did not look like she enjoyed it as much as he did. Anyway, all right.
To be honest, he didn't look like he enjoyed it very much.
He didn't look
either.
like he enjoyed it very much.
Maybe, yeah. It's just like an unfortunate thing he has to do of having enormous testicles all the time. He looked pretty proud of those.
He looked like he should not sit on a chair made of slats.
No, absolutely.
We'd never get up again. All right, so those are my two pieces of news. One silly, one quite less silly. Dirt. Let's talk about dirt.
Yeah, let's talk about dirt.
Obviously, I've read your article. I like your article. Very good article. Let's just be clear, though. Are you saying that dirt is good or bad?
Oh, I'm saying there are different types of dirt, Greg. I know. It's one of these ones where I'm like, let me just tell you about the nuance. It depends.
Okay, so this is going to be one of those really unsatisfying, nuanced, it depends things. Fine.
No, it's not. No, I'm going to give you some very simple rules to know if dirt is bad or dirt is good, and how much you need to really go into the cleaning.
And what to do about it.
And what to do about it. Yeah.
Okay, well then let's start with what people probably already know or think they know. Let's start with the downsides of dirt.
Downsides of dirt. Well, if you look really dirty in our cultures, you are more likely to be judged as being poor or being a lower social class. I think that is one piece. There's a kind of visual signalling piece in our cultures.
Yep.
2, if you are spending a lot of time in really dusty environments, that can be really bad for your lung health.
Interesting.
3, if you are absolutely covered in dirt, you can't see if you have injuries or infections, and it makes it harder to look after your skin if you can't see it.
Okay, that's like camouflage levels of dirt.
I mean, it is like camouflage levels of dirt. Yes.
Okay, cool.
And there are lots of types of dirt that can make us sick.
Okay. I get the feeling we're coming back to this types of dirt thing. Can we talk about upsides of dirt, though, before we get there? Give me some upsides of dirt.
Absolutely. Upsides of dirt. Well, it's well established that contact with certain microbes in dirt is really good for you. So it makes your microbiome more diverse.
Okay.
Makes your gut microbiome more diverse, interestingly.
Is this what we lick ourselves clean or something?
I think it actually is. We breathe it in, goes into the mucus in the back of the throat, we swallow it, goes into our gut microbes. So playing in outdoor, like playing in mud, is good for children's gut microbiome. I think it's
even
airborne.
if they don't eat it.
Even if they don't eat it.
Gotcha.
Yeah, absolutely.
Okay.
And it's good for adults to spend time in these environments. It makes their gut microbiome richer, and I'm pretty sure that adults are not gobbling the mud.
Wow, you clearly don't ever look behind you on a walk.
So there's a whole kind of immunological piece, microbiome piece around around getting dirty, playing in the mud.
Okay.
There are also behavioural pieces, because playing in the mud and dirt is really fun. It encourages children to spend more time outside, and they have all of the other benefits then that come with being outside.
The short-term and long-term, I guess, benefits.
Yes. Absolutely.
Okay.
The light levels, the movement levels, the social benefits, all of those kind of pieces.
Okay.
There are psychological benefits as well. So children who dig in the soil, dig in the mud, are used to feeling sliminess and stickiness and those kind of textures. I can see your upper lip curling. Yeah, the kind of gross textures. But that exposure helps to protect them against phobias and sensation problems in adult life.
Stops them turning into me. I got you. I hear what you're saying between the lines.
There's also, in terms of psychological ones, a really cool benefit in that exposure to one soil microbe called Mycobacterium vaccae, which implies it comes from cows. I don't actually know this. I was just suddenly thinking, I know the other cow TV
the other one that's labelled as cows.
It's not that one.
No,
yeah. But so that this exposure to this microbe seems to improve resilience to stress long term into adulthood.
Oh, nice.
Which is pretty cool.
I really
and that's
wanna
one
know
you find in the mud.
mechanism on that.
Yeah. And then finally, there's a kind of indicator thing where if you are dirty, it means you're not being washed too much.
Okay, yes, I think I see this. Why is that a benefit?
Because if we think about allergies, asthma, etc., we used to believe that they were caused by not having enough infections, not getting sick enough. That was called the hygiene hypothesis, which said that we spend too much time, cleaning bad things that can make us sick off our hands, and when we're not sick very much, we get allergies. That is pretty much disproved now. Instead, people think it's not what we're cleaning off our bodies, it's that we're cleaning them at all that is the problem.
Oh, okay.
So instead of saying the problem is that we aren't getting sick enough, it's actually the problem is that we're using so many chemicals to clean our skin that it makes holes in our skin and other body surfaces, lets in the things that we become allergic to, the allergens, the pollen, the dust mite feces, etc. And that makes our body have an immune response against them, which causes an allergy.
I remember you describing this as like a vaccine.
Exactly.
It's popped into my head. The idea that a vaccine has three components, right? Mm-hmm. The payload, or the thing you're trying to become immune to, a delivery system, in many cases a needle, but it could be a squirt it up the nose job or whatever. Not up the nose job, up the nose, job. And then the third bit is something to irritate the immune system and make it wake up and pay attention.
Exactly.
And I guess this, if I remember rightly, you're saying that the soap is the delivery mechanism because it makes holes in the barriers of the skin. It then allows in the payload, which is, I don't know, peanut oil or pollen that's on the skin. And the soap also trashes all the bacteria on the skin and lets in the little pieces of bacteria. That irritates the immune system. It wakes up and goes, oh, what's all this pollen doing in here? It must be making me sick. Now you're immune to pollen, and being immune to pollen is another way of saying hay fever.
Exactly.
Got it.
Yeah.
Okay, I'm with you. So, those were 1, 2, 3, 4, 5 benefits of dirt, like that. Now, you have, if I've understood your pros and cons there, you're talking about different types of dirt.
Yeah,
right?
exactly.
Good dirt and bad dirt, for want of a better phrase.
Yeah.
Just very quickly, you already said it. What is the difference between these two types of dirt?
Good dirt is dirt that doesn't make you sick.
Right, yes, okay.
Bad dirt that does make you sick.
So we're talking about specific harmful microbes.
In general, it's microbes. There are a few exceptions, but let's focus on microbes here, because those are the easy and most common ones that indicate when we need to be removing stuff off our bodies.
I'm now instantly curious about the exceptions, and I will ask you at the end.
Yeah, absolutely.
Okay, so how do you know if your dirt is good dirt or bad dirt?
So, bad dirt contains microbes that are likely to be able to infect your body.
Okay.
At a very, very basic level.
Sure.
So that means, where are we going to find microbes that can infect human bodies? We're going to find them in stuff that comes from humans.
Gross.
Yeah. Poo, vomit, blood, other things like that.
The sneezings of small
Oh,
children.
the sneezings, yeah. Forgot the sneezings and the coughings.
How can you forget sneezings of small children?
Disgusting.
You live with 3 of them.
Ugh, yeah, I know, but it's summer. I'm having a little bit of a respite at the moment. And stuff that comes from animals that are similar to humans. So if we think about the microbes that any animal contains within it or on it, the closer they are to humans, the more likely it is that those microbes will be able to affect humans as well.
To be clear, we're not talking about distance here.
No, sorry.
We're talking about genetic similarity.
Yeah, exactly.
I got you, okay.
So if we're going to think about animals that are particularly close to humans, well, we think first off about other animals that are mammals that are at the same body temperature as us, that have similar niches in their body to us. And the more similar they are to us in terms of diet, the more harmful their microbes are likely to be.
That makes perfect sense. And also, as an aside, for those who don't know, I used to be a monkey vet, and I worked with other monkey vets on occasion, and I would occasionally see them not wearing gloves or a mask, and it always freaked me out because monkeys are the biggest source of absolutely terrifying cross-species contaminations that exist because they are so similar to people.
Exactly. So monkeys, really risky. Bats also don't seem very similar to humans, but they've got a terrifying thing that you should be aware of.
Yeah, are we talking about the fever response here? Right, so can I do this one?
Yeah,
I love
do
this
it,
one.
because you're the zoology vet here.
Right, birds learn to fly bleeding years and years ago, and they're really good at it because they've got these funky lungs that have unidirectional airflow, lots and lots of oxygen gets in their blood, and they fly really, really well. Bats pop up, the new pretenders, and they're like, yeah, we're going to do birding, but we're mammals. We can't do the really cool lungs that birds can do, and we can't grow feathers. The best we can do is get really big, weird, flappy hands and hope for the best. So what they did was turbocharge their metabolism, and instead of running at, mid to high 30s like most mammals, they rock along at almost 40 degrees, burning through energy like you wouldn't believe. They have to almost hibernate every single night so they don't just starve to death, because they are running their metabolisms at an absolutely insane level to be able to fly. The thing with that is that a bacterium that learns to live inside a bat, or a virus that learns to live inside a bat, is used to a mammal that runs at 40 degrees. Now, if you remember the last time you were really sick, your body heats itself up to 40 degrees to try and get rid of bacteria and viruses. So those that come from bats, your body throws the last-ditch please save me fever response, desperately trying to cook itself free of bacteria and viruses, and all that does is make these things stronger. So diseases that come from bats, seriously bad news. Do not eat bats. Ever.
Yep.
Thank you. Important safety briefing, Egon.
Important safety briefing. Other animals to be cautious about. Animals that eat meat, because they're likely to have microbes in their guts that eat meat. Turns out you're made of meat. Let me just be very frank here. You do not want to be ingesting the stuff from those animals. So be cautious around cats and dogs. Also be cautious in general. Animals that primarily eat plants are lower risk, unless we keep them in environments where they're really stressed and unhappy, and we feed them on foods and they're not used to eating, and you end up with them shedding a lot of bad things. So be careful around farms. Farm animals as well are ones to be cautious of.
But if we were to put these in a hierarchy, it's don't eat anything that's come out of a monkey.
Yeah.
Don't eat anything that's come out of a bat.
Yeah.
Try to wash your hands if you touch anything that comes out of a carnivore.
Yeah.
And then maybe don't just go around eating cow poo.
Exactly.
On farms.
Yes, absolutely.
But there's a hierarchy.
There's definitely a hierarchy. And similarly, with birds, yes, there are things you can catch from birds, but you want to make sure that you wash your hands. You don't want to make sure that you just completely avoid birds for your entire life. Sure. And then we get down to our cold-blooded animals, and the microbes that live in those are probably generally less bad. Again, pet reptiles and things, they can carry salmonella. So you want to wash your hands. But the further we go down, frogs, fish, down to invertebrates, Greg, looking at you here.
I am not an invertebrate. How dare you? But yeah, absolutely. Look at me. The thing that we have to bear in mind here is that you're dividing dirt up into bad dirt and good dirt, and we're saying that normal soil is good dirt, and we're saying that stuff that comes out of animals is bad dirt. But as we all know, a lot of mud has been through a worm.
Yeah.
Right? So almost all dirt is dirt that's been through an animal. So there's a line here somewhere between I'm going to worry about that and I'm not going to worry about that. And I would suggest that that line is stuff that has been through an animal and still looks like it's just come out of an animal, or has come out of a human.
Yes, I think that is very true. So if it looks like poo, you want to wash it off.
Yeah.
But if it might have been poo in the last year or so, but doesn't look like it now, you're probably fine.
Probably all right.
Yeah.
Yeah. Let's not talk about anthrax.
No, that's true. There are always exceptions. But we also have to balance risk and benefit. And one of the things we do in our Western educated, industrialised, rich and democratic or weird cultures is we always focus far too much on the absolutely tiny risk and what we can do to minimise that without looking for the enormous risk that we cause by trying to prevent the tiny risk.
Yes. If you go outside, you can get struck by lightning. If you don't go outside, you are going to suffer from worse health for your entire life.
Exactly.
So in your article, which I very much enjoyed, you talked about once you'd talked about good and bad dirt and how to tell the difference. We then talked about ways to deal with both good and bad dirt without suffering those downsides of cleaning on the body, etc., etc. But the whole way through, we were talking about microbes. And right at the beginning of this, you teased us with there are exceptions. When is this not about harmful microbes?
I think there are a couple of pieces that I also consider with risk of dirt that isn't microbial, and that's usually around, I'm going to say quote unquote, chemical contamination, because everything's a chemical. I know that, but I'm talking more specifically about certain
Heavy metals?
Heavy metals, fertilizers, herbicides, pesticides.
Okay, yeah.
So that's on, heavily like industrial agriculture fields.
Okay, fine.
Also particulate pollution along the sides of roads. I don't stop the kids playing there, and they do, weirdly, it's quite compulsive to have a look and see what's alongside the curb. But we do always wash hands well, because they also they can disrupt skin barriers as well.
Of course, yeah. Nanoparticles of carbon. Weirdly, platinum from catalytic converters does weird things to the skin as well.
Yeah.
Interesting.
Do you have any others that I'm just trying to think with the children that you like?
If they were near no, I have no other reasonable worries. I have sci-fi scenario worries, but I'm not even going to go there. Okay. I think that wraps that up really, really well. Can I get a 1-minute summary?
So, it's really good for kids to get dirty because it helps them in a variety of ways. However, there are certain types of dirt that you really don't want to leave on children because it can make them sick. When you can identify what those types of dirt are, and typically, almost always, they are things that come from humans or other animals, you want to be able to properly clean those off. That's when you use soap. For other kinds of dirt, there are many ways to get them to get dirt off, and you can find out more in my article.
Solid. Like that a lot. Well, since we've done the news already, we've done the listener question already, and we've done the article, all that remains is for us to say goodbye. It's been a pleasure.
Goodbye.
Bye-bye.